Hi, I'm Ryan Mann, and welcome to this week's Wednesday Webcast. I'm one of the Innovation and Technology Specialists within the Business Support Unit here at the Southern Regional College. I'm primarily based on engineering, and within our team we have a wide variety of disciplines. This week, as part of our Wednesday Webcast series, I'm going to be talking through the benefits of 3D printing and how we use it here at the Business Support Unit. So we'll talk about what is 3D printing, its capabilities, and how it can be most useful within a product development and rapid prototyping environment.
So what is 3D printing? So 3D printing is also known as additive manufacturing. It's a way of creating a physical object from a 3D computer-aided design model. It does this by building up layers of material, one after the other, to create the physical part. So here at the college, we use a fused filament fabrication printer, where a length of plastic filament is fed into a heated extruder that deposits a thin line of it onto a heated printer bed. We use a raised 3D Pro 3 Plus printer within the Business Support Unit, which has a very large print volume and two extruder heads as seen here. These heads are fed from spools of material. We mostly use PLA plastic, as this is a great general purpose filament for prototyping. This means parts are strong enough to handle and test in the prototyping phase of product development. So this brings us to the question of why use 3D printing. So within the Business Support Unit, we can be involved in new product development with companies. It's standard practice to draw 3D modeled CAD files of parts as they're being developed. But often when a product is in the initial development stages, it can be helpful to have a physical part to handle and do some initial testing with. Getting hands-on with a prototype, even if it may be in a different material to the finished product, can be invaluable. 3D printing allows us to accurately, quickly, and relatively cheaply produce parts which can be tested, and this feedback can be used to iteratively improve the design. This isn't to say that finished products can't be produced on the 3D printer either. So as an example, I have here a CAD model for a spinner opened in SolidWorks CAD. If we imagine that we've been spending time with the company designing this, we've got to the stage where we have a fairly well finished model. We're able to pan around it, to interact with it as much as we can within a CAD package. However, 3D printing would allow us to see how it actually feels to use. This is actually another great feature of 3D printing. We're able to make parts fully assembled in a way that might otherwise be impossible. So this part we're going to print, and the center part is going to spin straight away, no assembly required. So all we need to do is save that model as a .stl file, and then we're going to open up our slicing software. In this case, we're using IdeaMaker, which is the slicing software that comes with our 3D printer. So a slicing software is used to break that 3D model that we've been working with in SolidWorks up into layers that our 3D printer is able to print. So here we can see a visual representation of our printer bed, 300 by 300 with 600 meter high. So to import our model, we simply go to our Import Model button at the top of our screen and select our STL file that we've just saved. And now we have a model pulled into our slicing software. So we now have our model loaded in. Sometimes whenever we load a model in, it will show up red, and that might mean that there are some issues with our CAD model. It might mean that we have features that are too thin. It might mean that there are some things that haven't been recognized by our slicing software. We can simply go up to the top and do an auto repair on those, which is going to solve that 99% of the time. So now we're able to interact with our model. We're able to move it around our print bed. We're actually able to raise it up off the print bed if we want. We can see there we're actually able to move it within 3D space. As that's there, we're also able to rotate it. We can rotate that around 3 separate axes, and we're also able to scale it, so we can make it larger or smaller. Again, here we're able to just drag it to enlarge it. So some of the other options we have then along the top of our toolbar, we can add in support material, And support material can be really useful whenever we have a print that overhangs or an element that's suspended in midair. So say we had dragged that into the air and wanted to put some support material in. So this support material is essentially a scaffold which the filament can be printed on top, and then whenever the print is finished, it is normally done in such a way that it's easy to break off without damaging any of the rest of the print. As well as manipulating individual models, we're also able to go up here, highlight a model, and then duplicate it. This is a really quick and easy way if you're doing multiples of the same object. So once we have our model in position and scaled correctly, we're able to go up to start slicing, and here you're able to see a variety of presets that we already have programmed. But to begin with, we go up to the top and select our printer type. In this case, we're using a raised 3D Pro Plus. You can see just below it there, since this is a 2 extruder machine, we're able to select the material used in our left and right extruder. In this case, it's PLA in a 1.75mm filament. We are also able to select what is being printed by each extruder. For instance, we could have our left extruder printing support material and our right extruder printing our actual model. You can see below here main templates that we have already used that have worked. So normally we have a high quality, a standard quality, and then a high speed. I have a few extra options added below there, but this is mostly going to control the speed and temperature as well as the print density of our models. So here we're able to go in and change our settings. In our simple settings, all we're really changing is our infill density and our shells. Our shells is essentially how thick our walls are going to be, and our infill density is how we're filling between those walls, then what percentage of that is going to be plastic. We're also able to change any platforms or support that we're adding in. So here we have a few different options for different platforms. So there's a few different platform additions that we might have. There's skirt, brims, or rafts, and then different combinations of the two. So here I have put skirt only, and we're able to slice it and then look at a preview of it. And here you can see where a skirt is simply printing an outline offset from our model. What this does is this allows us to prime our nozzle. Now we'll go back and show you one with a brim. So a brim is a single flat layer of extruded material around the base of the model. So this can be useful for increasing the adhesion to the build plate, to the print plate, and it also serves to keep the edges of our model down on the build plate. Now if we go back and we're able to add one in with a raft only, so we've done skirt, we've done brim, now we'll do raft. And a raft is then a thicker plate of extruded material beneath the model, so this goes right under it. It's essentially a bed that our model is lying on, and this has the effect of reducing the heat from the build plate. So our print plate that we're printing onto is heated, and this reduces the effect of that, as well as providing a sturdy foundation if you're building up quite a large model. So since this part doesn't require a skirt, a brim, or a raft, I'll go back up and go to one of my presets I have saved with no raft. So you can see there our layer height and our infill speed. So I'll start to slice that, and as this comes up, then we are given some information on our slice. We're told roughly our estimated time. We're also told how much material it will use, and then there's an estimate of the cost of the print below that. As a final check, then I'm able to go down and click preview, and this will give me a preview of, as we've seen before. I'm also able to go and upload to printer, which, if we're connected by a USB, will allow me to directly upload to our printer. And then normally I'm going to go down and click export, which allows me to export it to a USB pen to then bring it over to our printer and print from there. And here's our control panel on the printer itself. And here is a time lapse then of our product being printed. The great thing about our printer is it has an auto bed level, so it will go along and probe at a variety of different spots along the print bed to make sure everything's level before it starts to print. And there we go. Task finished and a successful print. If we look up here, there's our part. The beauty of our machine is that the print bed is removable. So you can see there our part's quite firmly stuck, but as we're able to remove our print bed, it'll pop right off as soon as it bends, and there we have a fully assembled and spinning spinner. Thanks for watching this short overview of 3D printing and how we use it here. If you're interested in any more information about 3D printing, about product development, or any of the other services we offer here at Business Support and Innovation at Southern Regional College, please get in contact. Look forward to hearing you. Thanks very much for watching.